Hello everyone, it is November 22nd, 2022. It's Geo-Rant time, Geo-Rant. Oh, I forgot. You'll see it in the title. I forget the number. But anyway, on Twitter I posted a poll, and the poll was, what is the most abundant element on Earth? And by abundant, I meant in number. I didn't mean in percent mass or anything like that. Just the actual percent, the number. And it's oxygen. It's clearly oxygen by far. There are more oxygen atoms that make up the entire planet than any other element. But that doesn't mean the mass is mostly oxygen. I need to talk about some things before I get into that. Basically, this is just a generic cross-section of the Earth. These are not exactly to scale. Crust, that's the outside here, and this is probably actually thicker than the real crust. Actually, it is, my black line. M is for mantle, and then here we have the core, the inner core and the outer core. Now, I just need to talk about some things here. When we see this, we often forget that Earth is essentially, for all intents and purposes, spherical object, and we're looking at a circle here. Now, the area of a circle, volume is just the internal area of a sphere. The area of a circle is pi r squared. The volume of a sphere is 1/3 or 4/3 pi r cubed. Just to give you an idea of how much that increases things from this to this, let's just do a couple of simple things here. Like if you take 3 and square it, you get 9. You take 3 and cube it, you get 27. Sorry, cat on the bed. I need to get him off. Get down. Now, which one is more? Well, obviously this one. And by a lot. 27 is a much larger number than 9 is. So you are doing essentially that and multiplying it by an additional third. So this thing is a lot more encompassing than it looks from a simple 2D diagram on a board, because the Earth is a three-dimensional object in space. So when you see this, and these are close, they're not exactly, the inner core is a little bit bigger. I had to trace shapes because my hand won't let me draw good circles. Let me move this over here a bit. But the outer core and mantle are about the same as you would see in a diagram. Their actual thickness in a cross section. Now you might be like, oh man, that's big. That's a huge part of the Earth. The inner core, which is the solid part, the outer core is liquid. I mean, it's big, right? Well, in volume, the inner core is less than 1% of the volume of the entire planet. It's the center of this onion, if you will. Now, the mantle makes up the vast majority of the volume of the planet. I did these calculations years ago. They will be linked if you want to see them for volume and mass. Kind of confirmed my methods were right. And if memory serves, the mantle is 80% of the volume of the Earth. And this is mostly oxygen bound with this, silicon. Silicate, for just using this generically here, I mean, this is one of the most common bonds on the planet, is SiO4, but these can be bonded in other ways. So I'm just going to say silicate mineral generically. Now you think of quartz usually, which is this. But these two things make up the majority of the mantle and the crust. The mantle is much more crust-like than it is core-like. It's made of a lot of the same elements that the two are. And actually, most of the mantle is magnesium. Is that right? Yeah, magnesium. It's not even iron, although there is a lot of iron in the core as well, but not really enough to answer the question everybody was trying to get to, which by mass makes up more of the Earth. Is it iron or oxygen? Now I said volumetrically wise, or not volumetrically wise, but count wise it's oxygen by a landslide. It's mostly oxygen. Now the mantle, although it's like 80+% of the volume, it's a lot less of the mass of the Earth because it's made of lighter things. Like I said, there's some iron in there, but it's not like the core, which we suspect is mostly an iron nickel alloy, about 80% of it anyway. Now, some of those estimates vary, say 85%, but here's the thing. The interior of the Earth is a lot hotter than we used to think it was, which means there's some sort of radioactive decay going on. We don't know exactly where that is. Is it in the lower mantle or is it the outer core? We can't tell these things from seismology. All seismology can do is tell us where these boundaries are and their relative densities, and we try to figure out what's there from that. We can't use the Earth's magnetic field either. Magnetic fields are not stable, even in short periods. Anyone who uses a Brunton compass knows that. Earth has a nice dipole magnetic field, but Mars doesn't, and that you can't use the interior. You can't get the interior of Mars from its magnetic field any more than you can ours. Now, so we got this stuff here, and this is our ultimate question: which is more, mass-wise, not number-wise? It is definitely one of these two, because this is mostly iron and nickel, but there's got to be some sort of radioactive decay going on to keep this heat in the Earth more than just what we thought it should be even 2 decades ago. So, but there's probably not a lot of uranium. Most of the uranium is probably in the mantle and crust. So the core is probably mostly iron and nickel, but there could be thorium or other stuff in there. And if you increase the amount of iron, or if you increase the amount of radioactive elements, especially heavy ones, heavier than iron, you've got to lower your mass of iron and raise your mass of lighter elements, such as sulfur is probably a really big one in the core. And there could be some oxygen too, but probably not enough to really factor into this stuff. So that would lower your percent mass of iron. And here's the thing, I have never seen, I've been searching and searching, I have never seen any calculations on this. I'm trying to work through it myself. I've seen numbers. If you go to Wikipedia and you go in there and you're like, hey, what percent is the Earth iron to oxygen, not the crust? Make sure you're getting the entire planet, not just the crust, not just the mantle, not just the core. And you'll find out they're both really close to 1/3. Wikipedia has iron winning out. It's closer to this. Oxygen is more like 3/10 or 30% as opposed to 33, somewhere between there. So if we increase oxygen for any reason and decrease iron for any reason, this could flip. They're real close to each other according to Wikipedia. I've just begun running the calculations. I don't know what they are for sure. Now remember, the Earth is cooling over time. It's not as fast as models used to predict. But here's the thing. The mantle and crust compositionally are a lot more similar to one another than either of them are to the core. We don't suspect the core to have a lot of crust and mantle type minerals in them. Remember, the mantle is a solid. There's crystals down there of rock. It's just under a lot of pressure and it behaves very plastically. So over time, what is happening? The mantle is not getting thicker. The crust is getting thicker at the expense of the mantle. But this right here, the mantle compared to the core, or the crust mantle, the crust and the mantle compared to the inner and outer core, are about staying the same in thickness and volume over time because of the significant chemical composition differences. Now, Earth differentiated itself for whatever reason a long time ago. So your core, what's happening is your inner core is getting larger. It's becoming more solid as Earth cools. That allows this liquid outer core to solidify, making the inner core larger over time at the expense of the outer core. Just like the crust thickens at the expense of the mantle. volumetrically, we have about the same, we have more crust on Earth than we do the inner core. It's just spread out over the entire surface of the planet. And I forget how much mass the inner core is. I want to say it's maybe 2%. And just go look at my videos. I'm sorry. I've had a long day, and I just thought I wanted to get this out here for you here so you can see where I'm going. Now, I don't know exactly where this is going to take me, what my numbers will be. Now, I'm going to have to make a lot of assumptions. My mass and volume videos are based off assumptions, but they worked. They cross-checked one another, so they're reliable. But this is going to have to be more assumptions because none of the numbers match. They vary plus or minus a couple percent, sometimes more like 20%. I don't know why that is, or not 20%, sorry, 10%. So the numbers, I'm going to have to use my best judgment and pick from the most reliable sources and what my experience tells me about the mass of these things. All right, so yeah, it's going to be a mess, and we'll see what I get. I should, if that Wikipedia article is anything, has any weight to it, mass to it, not weight, bad joke. Anyway, I should get somewhere around these numbers, but I actually suspect that when I do it, the maths, just from what I've been looking at so far, that oxygen is going to be the winner, and probably by a lot more than really close. But I could be wrong on that. See, there's so many things we don't know about the interior in deep scales, because we can get the densities and we can get the boundaries. So we play with numbers to see theoretically, well, maybe it's mostly iron and nickel, or maybe it's a little less iron, more nickel. And like I said, these vary a lot as it is, and this could flip these easily. Now, it's not just all guesswork. We have done high pressure, high temperature experiments to see what we can get, and it is. The core, if we somehow manage to drill down to it, which has never happened, it would be mostly what we think it is, probably or close to it. It'd be iron and nickel mostly, with sulfur probably being the biggest next one. I guess. But I'm never going to live long enough to eat those words. So that's what we do. We make our best guesstimates with what we know and how it fits, and then we run these experiments to try to see if these things work out. So I will just be playing with numbers. Obviously, I have no way to experiment on the core or to run any high pressure, high temperature experiments to see what happens and with what elements. I don't have that ability. So I will be doing numbers, and Thanksgiving's coming up. I'm going up north, so I will be gone. I'm going to be in Canada. Actually, my prospecting license expired on my birthday, so I got to go out there and take care of that. And I'm going to stop at a couple of stops near the Wawa area because I'm going to update that book that goes to the North Shore of Lake Superior, as well as probably the other one. I forget which one it is off the top of my head. Let me do this. Since we're already going here, I might as well as do this here for you. I'm going to, not the Sudbury one, the roadside book, probably this one. And I'm coming back, I swear, super for reals, guys. These two. This one, which is number 4 in the guidebook series. I will probably put the Wawa one, or my, there's an awesome banded iron formation on highly deformed on top of an undeformed Archean basement rock at a road outcrop. I was aware of that outcrop when I did this book. I just didn't know where it was, and now it's all over the interwebs where it is. So I should be able to find it quite easily. And then I will also update this book with updated charts and things like that. And for some reason, I can't seem to find my map. Anyway, and then I will be redoing this book as well, the North Shore, because there's a couple more I want to look at. This should have an updated map in it. Yeah, this one here is this right here, volume 4A. 4B goes this way, and I'm going to redo this one as well. The outcrop is about right there, but there's a place over here with another banded iron formation, the Helen. This hasn't, the BIF you're going to see with the deformed, and I'll probably do Geo-Rants or Geophiles in the field, whatever, with the high deformation. We don't, or I don't know what formation that's attached to, if any. It's just a narrow outcrop. And then there's a couple, like, there's like an outcrop with really big xenoliths I'd like to take you to, which would be in this book. So these two books will be updated, not before the holidays. That's not going to happen. I was thinking about trying to get this one, but probably not going to happen. Anyway, that's it. If you have any questions or comments, please leave below, and I hope you learned something.